Welcome, scientists! I'm Professor Ali with Professor Egghead, and today we're going to talk some more about sound. As you recall, we have talked about sound before, and there is plenty, of course, to learn about sound. So let's get started with our first example. Now, this isn't an experiment per se that you should do at home. It's not really necessary. This is solely to show you an example of how sound moves through different mediums. What do I mean when I say that? Well, sound has to move through something, right? So is it moving through a solid, a liquid, or a gas? Now, often when we speak and the sound moves through the air, right? So that's an example of sound moving through solid, liquid, or gas. You guessed it, gas. Yeah. So that's an example of sound moving through gas. But when I put my ear up to a wall and someone's having a conversation in the other room, where is sound moving through when I'm holding my ear to the wall? A solid, a liquid, or a gas? What's the wall? It's a solid, right? And then one last state of matter that sound can move through would be, you guessed it, liquid. Now let's examine which state of matter sound moves through the best. Now I want you to think about different experiences you've had with sound in your life. And I want you to make an educated guess. Does sound move, which is a hypothesis, does sound move through a solid faster, a liquid faster, or a gas faster? Now here's the not experiment. Here's the model I'd like to show you. Here we have what we're going to pretend is gas. And here we have what we're going to pretend is liquid. Last, we have what we're going to pretend is a solid. Now, ask yourself, which state of matter does sound move through best? A gas, a solid, or a liquid? In order to show you what I would like you to get a better understanding of, if you aren't sure already, is how sound moves through these different mediums. So today I have a little bit of red food coloring, and that will represent my sound. And here in these cups are some materials that will represent gas, a liquid, and a solid. So let's see how sound moves through a solid, shall we? So what I'm observing, and what you're probably observing, is that the sound moved through this solid pretty quickly, right? It changed the color of this material. Now, let's see how sound moves through a liquid. It's a little slow. It's doing its job a little bit, but still a little slow, right? Okay. So, it's kind of just sitting on top. It's not really moving around. Let's see if I move this a little bit around. Okay, it can move through. It's just not very quick, right? All right, so now what about a solid? This is our example of a solid. Oh, I'm sorry, this is our example of a gas, excuse me. We already did our solid. Wow, well that's really sitting on top. Oh man, and this is really sticky here. It's definitely not as easily moved through as the liquid, and definitely not as easily moved through as solid. So in this example, we can see that sound, our food coloring, moves through a solid the fastest, a liquid the second fastest, and a gas the slowest. Now, The reason sound doesn't move through a gas as quickly is because the particles are spread out. The molecules are spread out in a gas. In a liquid, they're less spread out. And in a solid, they're really close together. So the sound waves are able to move through much faster. Let's see some other experiments with sound, shall we? All right. So now that we see how sound moves through different materials, we can talk a little bit about sound waves. All right, so first of all, if you do want to do this experiment at home, you probably can, because if you have a piece of spaghetti, like this, and you have an uncooked spaghetti, and you have a little piece of clay or a marshmallow, all you have to do is take that little piece of clay, a tiny ball, or a piece of marshmallow. Mini marshmallows are great for this, but if you just have a large marshmallow, you can just take a little piece of it. And now you take one end, the opposite end of the spaghetti, and you try to move that piece. Wow, okay. Well, it's tough to move it, right? And you might even break it. Oops. You can just try again if you break it. Keep going, keep going. Woo! It's taking a while for the movement to get to the molecule, right? But if I have a shorter piece of spaghetti, I can move that molecule a lot more easily, right? And it oscillates. It moves up and down very quickly, right? So, with a shorter wavelength like that, we can get the molecule to move a lot faster, right? So, this is an example of how we get our frequencies, right? This would be an example of a high frequency because we're moving it up, we're getting the molecule to move up and down a lot faster. High frequencies sound like this. Ah! Now the other example that I showed you earlier with the long piece of spaghetti, that long sound wave, let me get another one, I already broke it again. The longer the piece of spaghetti, the longer that sound wave is, the lower the frequency. This type of low frequency creates a low pitch sound. So before we were creating a high pitch sound that sounded like oh, right? And this type of frequency, this lower frequency, sounds like oh, right? It sounds lower than a high frequency that you get. So now that you understand pitch and frequency a little bit better, I'm going to show you a cool other experiment. You might have seen this experiment before by Professor Egghead. However, I'm going to show you how to break it down. As long as you have adult supervision, you could do this experiment. All you have to do is get two plastic straws. You put one plastic straw inside of the other. And with that adult supervision, the adult might end up having to be the one who does the experiment, or at least in the beginning does it. So allow your adult who is supervising to help you here, because this is actually very challenging. It was very challenging for me as well. And I've done it a lot, and it's still challenging at times. So I'm going to make sure that this isn't too small inside the other straw. So I'll use that as my front part. When you are putting your straw inside of the other straw, try not to bend it too much, because you still want the air to pass through. All right, so now I've got it. All right, now the very end of your straw, one end of your straw, should be cut, and this is especially why we want adult supervision. It should be cut into a V shape, okay? You want it to have a point, like an arrow or a V. So the very end of your straw should have a point. And then we just kind of want to flatten it out, all right? So you're going to make a pretty cool instrument right now. Now, before you can make this instrument, you have to learn how to make the sound. You could just blow in it, and it won't make any sound. So what you'll have to do is you have to make this sound, which you might have made before. It looks really silly. It goes like this. Can you do that? You have to kind of hum at the same time as you're pursing your lips like that. So this is how it sounds. And all you're doing is you're going to feel that vibration on the ends of your lips. You're pushing air through, and you're also making noise. So you could just push the air through like this, but it helps to make the noise too. All right? All right, so let's see how it goes. See how hard it is? That was a lot of work. Thank you. Thank you very much. And you will understand why I say it is a lot of work once you try it at home, because it is not an easy experiment to do. Why was the pitch higher as I cut the straw? Something to think about, right? Well, as I was showing you before, with a shorter wavelength, we had a shorter space, a shorter amount of the medium to move through. So the oscillation, that movement up and down of the molecules, was much faster when we had a shorter straw to work with. So over time, as I kept cutting the straw shorter, the frequency was much faster, causing the pitch to be much higher. So you had, right? You had the sound go much higher in pitch as I cut our medium, our straw, shorter. So I was only allowing so much room for the sound waves to pass through, right? Okay, friends, it is time for our last experiment, scientists. So for this experiment, you need a cereal box. And this one is great for adult supervision too, just to get the rubber band around the cereal box mostly. Apart from that, really, if you have adult permission, you should be able to play this instrument on your own after you've constructed it. So you want to take your rubber band and you want to make sure that your rubber band is a big enough rubber band that it fits around the outside of your box. Now, when I say outside of your box, do I mean this way? No, I mean the very outside. The one with the greatest perimeter, right? So if you know what a perimeter is, it's the outside, the one that has the highest number of inches around the perimeter, right? So you're going to get a larger perimeter around the outside where the nutritional facts are. So the skinny side of your cereal box is where you want to put your rubber band. Think of it as this. If you didn't want somebody to eat your cereal, you'd probably put your rubber band around it this way, right? Because then you're blocking them from getting in, right? Okay, so now lay your cereal box on its long side, just like this. Okay, so once you've laid it onto its long side, you want to take 2 markers. They should be thick. They could be like Crayola thick markers. They could be Sharpies. It's helpful for them to be a little thicker. They don't have to be as thick as mine, but a little thicker is good. It still works to use pens. This just gives you a little bit more space in between your rubber band and the box. All right, so now's the part where we get to make our sound. Nice. So that sounds kind of have that sound kind of had a low pitch, right? A slower frequency. It's a low frequency, which results in a low pitch, right? So now what do you think will happen when I shorten the space between the 2 markers? Do you think we will have the same pitch or frequency? Do you think we will have a higher pitch or a lower pitch? Make your hypothesis now and then give it a shot. You can even put it on pause if you want to take a moment to write your hypothesis down. All right, here we go. Is that a higher pitch or a lower pitch? It's a higher pitch, right? So the farther our markers are away from each other, the lower the frequency, right? The lower the pitch. The closer they are to each other, the less space there is between the rubber bands, causing our sound waves to move faster. The molecules will vibrate faster, right? They move up and down a lot faster, causing a higher frequency, right? The speed is faster. We have a higher frequency, which causes the pitch to go up. We have a very high pitch. Cool, right? Now, just for one extra interesting fact, there are frequencies we can't hear. So, go ahead and make a humming noise and hold your fingers on your vocal cords. So, what happens when you create a low pitch sound? What do you feel? What do you feel when you create a high pitch sound? So, what you may be experiencing is that when you create a low pitch sound, you can feel the vibration much more easily than when you create a high pitch sound. The reason you can't feel the vibration when you create the high pitched sound is because the molecules are moving so quickly, you can't even feel them. That's how fast they're moving. But when you create the low frequency sound, they're oscillating up and down, they're moving up and down more slowly, so you're able to feel it. Now, imagine there are sounds outside of what we can actually hear, right? You may have already heard dogs can hear a higher frequency. They can hear really, really high-pitched noises that we can't even hear as humans. And elephants can communicate in very low frequencies, so low that we can't even feel them. Isn't that awesome? All right, that's it for today. Thanks, scientists, for joining me. I'm Professor Allie with Professor Egghead. It was great to have you again. Please feel free to follow us on Instagram, to like our Facebook page, to join classes whenever you decide you'd like to join. They're interactive and we'd love to have you. Again, go ahead and subscribe to our channel and we'll see you again next time. Have a great day. Bye.